welcome. If you love regular expressions, you might enjoy this. If you hate them, you might enjoy this. If you're confused about what they are, you might like this. It might be helpful. If you know everything there is about regular expressions, you must be God, because I don't think anybody knows everything about them. It's a very deep subject. Okay, let's go ahead and get started. Yes. Can I get, if I'm a little closer, is that better, or we have a general volume problem? Oh, okay. I'll try to speak up. Okay. I used to teach a Perl class on the side, and the regular expressions unit was an entire day. So here we're going to try to cover everything and more than we covered in that class in less than an hour. So let's get moving. So if you've never been exposed to regular expressions, then this should help. However, we're going to go fast because there's a lot of material to cover. And even if you're pretty well versed in regular expressions, there's probably going to come a point where you'll get lost. And don't feel bad. I do invite questions anytime if you have a question, but if we start getting bogged down, I will just have to move on because there's a lot of material to cover. Some terminology. Regular expressions is a lot of syllables, and so we often call them RE, REs, or regex, or regexp. I will be using REs in this course. Unicode and regular expressions is a large topic. I'm not going to cover Unicode in very much depth. I'll just touch on it a little bit so you'll get some familiarity where Unicode is an issue. But there's a lot of depth there, and we don't have time to do that. That's a course in itself. So what we're going to be doing is we're going to be going over and defining what a regular expression is, a little bit of history behind them, how to use them, a lot of syntax, talk about the operators and modifiers, and talk about some common idioms that you use and some common mistakes. And talk about strategies in writing them, how to debug them, talk about some of the Perl regular expression modules that are out there that help us with these, and then some advanced topics, things you'll probably never run into anywhere else. We'll talk a little bit about optimizing performance. Most times, regular expressions aren't a big deal for performance, but sometimes they can be a real problem. And then just to give you some exposure about how other languages deal with regular expressions, we'll show you some similar code in various languages so you can see how Perl compares syntactically with some other languages. And then maybe we'll have time for some Q&A. So a regular expression is a description of a pattern of characters in a string. A regular expression uses characters and what we call meta characters to describe this pattern. Now, regular characters are just themselves. Meta characters are characters that represent something else, something other than themselves, a group, an operation, an option, something like that. Some history behind regular expressions is the whole concept of a regular language, which would give us a regular expression, was started in 1951 by Steve Klein. It was interesting is the snowball language actually was based on pattern matching. Either a statement succeeded or failed, but it didn't use regular expressions, but it was doing patterns. And this is, I actually programmed in Snowball in college for fun and found a bug in the Snowball interpreter. It was kind of fun. In 1968, the first consistent use of regular expressions in editors and compilers began, but it wasn't in a language yet. And you're probably familiar with grep. Grep was one of the early adopters of regular expressions. Later, it came to some other tools like sed and awk. In 1987, when Perl started, it was using Gosling Emacs regular expression engine. But when we went to Perl 2.0, it switched to Henry Spencer's regular expression library. Perl has become the de facto standard for regular expressions. It ended up formalizing as the POSIX standard. And you think that might be great. Perl's success has been copied to other languages, but because of this, success, it's part of its decline because you can do stuff now in other languages that you could only do in Perl. So the purpose of a regular expression is to find a specific string or some data or a type of data and extract it, act on it, manipulate it, somehow do something with that. And so what we're looking is, does this string have a pattern in it that this particular pattern? Does it have the thing I'm looking for? If it's so, do I want to pull it out? Do I want to modify it? Put it in another put it in a spreadsheet, put it in a file, whatever we want to do with it. That's the purpose of it. So we're going to see that here. Now, Perl is actually its own, regular expressions are actually its own little language inside of other languages to match specific patterns and characters. Each character by itself either has its own meaning or it modifies a meaning of something else. And it's very tedious to read at first and very concise. So how you actually use regular expressions depends on the language. Now, Perl, it's used with match, substitute, and split operators in a few other places that are minor. It tends to appear more native in Perl than in other languages or tools. But we're going to cover what it looks like in some other languages, tools like grep and Java, C#, and so on. So in this presentation, for the most part, regular expressions will be always represented in red, and the strings to be matched will always be represented in blue. So first off, we have just regular characters. These match themselves. So if you put an A in a regular expression, it's going to look for the character lowercase a. If you put a B, it's going to look for a lowercase b, and so on. Most of the characters in the character set work this way. They're not special. So if we look at a regular expression ABC, it will match the string ABC. It'll also match the string ABCDEFG and 1, 2, 3 ABC 4, 5, 6 because it has that ABC in there. We haven't said where that ABC needs to be in the string, just that it needs to be in there. And if you notice that ABC as a regular expression does not match ABX, C, or a completely unrelated character string fig. Next, we have meta characters, and this is where it starts getting kind of tedious and ugly. Meta characters define some aspect of a group, control, or modifying another character, adding or removing special meaning from another character. These are some examples of some of the meta characters that are out there that we use: square brackets, the parentheses, star, plus, the backslash, $, and so on. There's a number of them there. We'll talk more about them later. One of the most important constructs is that of a character class. A character class lists a group of characters, and this is very important. It matches only one character. If we want it to match more, we have to tell it we don't want it to match more, but it just by default, it only matches a single character. So if we have in square brackets a list of characters we want to match, like ABC, it'll match just an A or a B or a C. We can do a range with using the dash. So A to Z would mean any lowercase alphabetic letter. If we put a caret as the first character in a character class, it negates the class. This is where the position of the caret character is very important. If it's anywhere else in that square bracket box, it doesn't negate it, only if it's the first character. And so here we're negating 0 through 9. So we're looking for anything that is not a digit. And in a character class, in general, the order of the characters that you list in there are irrelevant. It's just looking for one of them. If you have a range, you have to have a dash, so then the order is important there. If you have a caret, it's got to be at the beginning if it means to negate the class. Yeah?
Would the percent sign in there possibly have a parsing issue with character classes?
It's not an issue. Remember that hashes do not interpolate. So we have some predefined character classes. And by the way, this is a Perl extension that's beyond what grep began with. So this is actually very convenient. These character classes are a shorthand for sometimes a very large, tedious character class to write out. So dot means any character except new line. Some people forget the new line part, but it means any character but new line. And we can change that if we want later. I'll show you. /d is the same as 0 through 9. So it says we're looking for any digit. This gets us into a little trouble with Unicode because there's some numerics that are not 0 through 9 that are part of other languages. So in this case, Unicode will kind of trips us up. But the normal stuff you'll be doing is 0 through 9, so it'll match a digit. /s is a white space. And that also can be changed in Unicode a little bit. And there's been some modifications to that with vertical white space and stuff in some locales. So /w is the same, is sometimes thought of as a word, but keep in mind that this is an alphanumeric and underscore. So lowercase a through z, uppercase a through z, 0 through 9, and underscore. It's not a word. It's a single character. So don't fall in that trap thinking it's a grouping. It's a single character. And then if you capitalize those letters, then they become a negated version of that class. So / uppercase D means anything that is not a digit. / S, anything that is not a white space. And of course, / W, anything that is not an alphanumeric or an underscore. We can extend those predefined character classes by putting them in the square brackets and making a new character class. So for example, /w dot, in this case, when you put a dot inside of square brackets, it means dot. It doesn't mean any character. So here we're saying alphanumeric or underscore or dot. And then the dash, /d, e, lowercase e, uppercase e, and a dot would be a floating point number. It's not saying it's in a correct floating point format, but it would be that that character could be in a floating point number. Now, up to this point, we've only defined what a single character in a pattern can be, a character class, or a single normal character. Now we get into the tricky stuff where we want to have groupings of these. We want to have multiples. We do that with our quantifiers. And so the quantifier goes right after the character or the character class. It modifies the thing that's right in front of it. So it matches it applies to the thing in the left. So the star is a quantifier that means match 0 or more of the preceding thing. Plus means match 1 or more of the preceding thing. Question mark means we want 0 or 1 of the preceding thing, meaning that preceding thing is optional. If we have a notation with curly braces that tells us an exact number we want, for example, here we want 5 of the preceding thing, or if we have a comma after the 5, we want 5 or more. So there's no upper limit there, or a specific range, 5 to 7. So here's how you could use some of them. So if you put a plus after the 0 through 9 character class, it matches an integer of 1 or more digits. So the /w dot and a dash would match a domain name. We can put a question mark on an E in the JPEG, and it'll make it match either JPEG GPG or JPEG. Sometimes this looks a little funny when you see a question mark in there. You have to look at the context. Question mark is overused in regular expressions. So you have to know exactly what it's following to tell what it means. So in this case, it means that E is optional. Yes?
Does the dash always have to come at the end of a character group, or is there a way to put it?
if you put it at the beginning or the end, it's not going to be a range. If it's a nonsense range, then you're gonna it'll interpret it as a dash. So yeah. So you have to be careful where you're putting it. Some people get nervous about it, and so they backslash it to make sure that it sees it as a dash. I'm really hesitant to backslash things we don't need to, just because regular expressions are already ugly enough, and let's not make them more ugly.
I asked her if I usually backslash. I'm not sure.
I know I get a bunch of grief when I do code reviews at work where I will tell them this is the proper style to use with Perl. And they say, well, I'm more comfortable backslashing it or quoting it. And I'm going, well, you don't need to. And so it makes everybody else think that it's supposed to be that way, and it's not. And the thing about Perl is the style of Perl is actually to make it as brief as possible, less clutter. Yes?
What is where the junk syntax doesn't make anything?
Yeah. Junk syntax doesn't make anything clear. Good point. I like that.
You backslash all of them every time.
Yeah. 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 You got to learn the syntax. \d star between some colons means we're looking for an integer between some colons or an empty string between colons, because it will match 0 or more, meaning an empty string. Now, the behavior of the quantifiers is that they're naturally what we call greedy, meaning they want to give you the largest possible match. And sometimes this can get us in trouble because we didn't want the largest possible match. So, for example, in red here, we've got dot star, comma, dot star. You would think that comma would be caught as the first comma in the string, but it'll actually be the last comma because the first star is going to eat up all the characters up until that last comma in the string. And it turns out at this point, it doesn't really matter. But when we start manipulating strings, we're going to care about which comma that actually is. So we'll talk about that. So there's something as known as non-greedy or lazy quantifiers, where what you do is you modify the existing quantifier like a star or the plus or the question mark and tell it, instead of getting the largest possible match, make it the smallest possible match. You still want it to match, but you want it to be small. And so what we do is we put after the quantifier, we put a question mark. Here's another use of the question mark. And so it minimizes that quantifier. So in the case with the comma, when we put the question mark after the first star, it'll now match that comma as the first comma in the string, not the second. In the literature, you will see this term as non-greedy. Sometimes you'll see it called lazy. There's some other terms, but those are probably the most common you'll see. This question mark to make us these quantifiers lazy or non-greedy works with any quantifier. So we can put it on a star, we can put it on a plus, we can put it on a question mark. We can even put it on the curly brace range thing, like the 4 to 6. So it'll try to give us 4 if it can. But you have to be careful with this. Dot star question mark matches empty string because it wants 0 or more. So it'll say, well, the smallest is 0. So there we go. So if it can match 0, it will. Now, there's another type of meta character called an anchor. These do not match a character. They match a position. So the caret, another use of the caret, means beginning of line or the beginning of a string. The dollar sign, and if you're familiar, if you're used to VI, you're used to dollar sign being the end of the line. Well, dollar sign kind of has a funny meaning because it means end of string or end of line or the record separator at the end of the string. Or if you have multi-line string, it could be the record separator in the middle of the string. So it's a little tricky that way. Because of this, there's some alternate forms where you can use a \A, which means the literal beginning of a string, and a \z, which means the end of a string. So it's not ambiguous. You don't see that used all that often. There's some people that are really careful. They will do that. Most people are lazy and kind of use the caret and the dollar sign. And for single line strings, you're probably okay. But you will see that a lot. But you will see the A and Z in there. Some of the advanced Perl regular expression stuff that you will eventually end up doing at some point is in slurping an entire file into a string, into a single scalar, and then matching along that with a regular expression. And so you will have embedded new lines. This can give you great performance improvements. I knew a guy who had some log files he had to process. They were 2 gigabyte log files, and he was reading them a line or a record at a time, and it was taking an hour to process this log file. Yeah, it was slow. And so when he learned how to slurp, get that whole file into a string with embedded new lines, all of a sudden his processing went down to 2 minutes. So a huge improvement. So this is something you will want to know about, and I'll show you some ways to manage that. So in the advanced section, we're going to talk about some other anchors that are positions other than the beginning or end of the line that will match a position based on a pattern. But we'll talk about that later. The next thing is captures, or sometimes called tagging. This is where we have a pattern that we want to match and pull that thing out and do something with it. And that thing that we're going to do with it, we may save it in another file, we may use it in an expression, generate a string, to an output, and goes into a database, who knows. The way we capture that is with parentheses. We put parentheses around the part of the expression we want to capture. Now, when you normally do that, it will put the matched part of that pattern that in a variable called $1. If there's multiple groups of parentheses, it'll put the next one in $2. And there's no upper limit. You can have $85, $86, $87, $112. Of course, if you're getting that many captures in a single regular expression, you're probably doing something wrong. And the upper limit is in several K. If you want to use a matched or a captured value inside of a regular expression later in the same regular expression, you can do that with what's called a back reference. And you say \1 or \2, \3, and so on. So for example, here we have an alphanumeric of length of 3, and then we say \1. Now we've tagged or captured that /W3, so it'll find 3 alphanumerics in a row, followed by the same 3 alphanumerics in a row. So it finds that repeated pattern. Now that back reference also will set the $1 variable. So you'll have that pulled out as well. So you know exactly what matched. We could put a .* and capture that between repeated bookends, essentially. And it can save those as well. Some pretty cool stuff. We have the alternation, the or. So we can say cat or dog. Or we can say we're looking for cats or cat. Now we have to use parentheses around sometimes with an or sometimes, because otherwise parentheses allow us to group. Otherwise, we'll end up saying the entire left side of the regular expression or the right side of the expression. And we want to just say, well, these two things that are a subpart of it. We'll see more of that a little later. Now, if we notice that I said cats or cat, if I had said cat or cats, it will never match cats. It'll only match cat. And that's because the or is evaluated left to right. And as soon as it finds a match, it's done. So regular expressions are always evaluated left to right. This is very important. It actually has pointers that go through the pattern and the regular expression and the string. And they're going back and forth. You'll see this when I get to the demo part of this, how that actually works. And it will stop at the first match. So on the or, it'll never get to the right-hand side if the left side of it matches. We can have multiple groups. So if we have an example, and we can have nested groups as well. Cat or dog is angry or sleeping. The match of the string of the cat is sleeping. We'll end up with $1 having the cat is sleeping because it's the larger group. The left parent is the first one it encounters. So that'll be in $1. The next parent it gets is cat, going to be cat or dog. So it's going to match cat. And then, of course, 3 is sleeping. Now, the operators that we use regular expressions with, we have the match operator. It's a Boolean conditional. It returns a 1 or an empty string as long as you're using it in scalar context. Like if you're saying, if this matches, then do this. That's what that's for. We do the match operator is actually 2 forward slashes with a pattern in between them. It operates on $_ by default. And if you're not used to $_, that seems a little weird. That's normal for Perl. Or we can bind it to a specific scalar variable using a binding operator. And so the equals tilde is the binding operator. So the example here we have if ABC, and what it's saying is if $_ contains ABC, then it'll say found ABC. Or we can say if $X contains ABC, then it'll say found ABC. Now, just like in a lot of other places in strings and so on, we have the backslash operator. It's placed before a character to either add special meaning like /D or to remove special meaning like /+. So we can actually search for a plus character. If we have a match with lots of forward slashes in it, we have to backslash those. So it starts getting really ugly. But there's an alternative, is that if you place an M and then a character, that the next character after the M becomes the delimiter instead of the forward slash. So it can make your code a lot more readable. And you can use just about any character. Some of them are not wise to use. I'll show you an example of a really poor choice. Commonly, you see curly braces. If it's a left-right type thing, you need to pair them up. So you can't use a right square bracket with a left curly brace. You pair them up with the types. If we put a match in list context, then it will return a list of the captures or tagged items. So here we're pulling out first and last. Or we're pulling out a domain and a path out of a URL. That's the match operator. We have a substitute operator, which has 3 forward slashes, and we have to use the S. The first part is the pattern that we're matching for. And then the thing between the second and the third slash is the replacement. When it finds that match, it replaces it with that. It also uses $_ by default. We can use the binding operator equals tilde to have it bind to a specific string. And substitute will return the number of replacements made. Most of the time, we don't care the number of replacements, so you will often see substitute on a line by itself. So example, we're replacing Robert with Bob, substitute Robert with Bob, or we can substitute .org with .com. Yes, question?
It's more of a comment. Let's talk several things that you know before. This one is going to save you lots of time, escaping things now. On substitute. I had no idea.
Yeah, you can use different ones, and that's why I wrote that example, is so you can see the use of two different paired delimiters there.
Really useful for switching something that also happens to one of your delimiters.
Yeah, it's actually great. So here's some tips. Don't ever use the M with the forward slashes because it's redundant. Just use the forward slashes. If you have another delimiter, then you can use the M, and that's fine. And here's some examples of various delimiters that we can use, and just make sure you use them in pairs. Now here's a bad example. Do not use a letter as a delimiter. So the S space S does evils is actually the substitute expression, the substitution operator. You have to put a space after the S so that it will recognize that the next character after the space is the delimiter. Don't do this. Modifiers allow us to change the behavior of the regular expression engine. So for example, when you have a match operator, it matches the first item, or stops after the first match. With a substitute, it stops after the first substitution. We can change that behavior by putting a G after the closing delimiter, and that means do it globally. Replace all of them. We can use an I to say ignore case, so we can match upper and lower case. We can put an S there. That changes the behavior of the dot. So the dot no longer means any character but new line, but means any character including new line. There's a lot of these modifiers. I'm not going to go into every one of them. M tells the regular expression engine that the string contains multiple lines, and this is useful if you have end of line or beginning of line indicators inside the pattern. And it's often used with G, so you can essentially have the regular expression looping over the expression and returning a whole list of things. I'll show you an example of that later. X allows us to ignore white space and comments, so it'll ignore pound signs and things after pound signs. That's a little bit of a problem. E allows us to evaluate in the right-hand side of a substitution, so the replacement portion, so we can put any Perl expression there. And this is useful if you have a function that like converts hex to decimal or something like that, or a character to a hex number, something like that. That can be very useful for that. R actually returns, when you do a substitute, it returns the substituted string but doesn't change the original string. The normal behavior is to change the original string. But R just returns it instead of returning the number of substitutions. N turns off capture. So the parentheses mean grouping only. There's an O, it's don't use it. LD, A, and there's U are actually Unicode related. Telling it it's ASCII or to use Unicode rules. I mean, it starts getting really ugly. And just be aware that that's an issue. You probably won't have to use those unless you're dealing with Unicode. Did you have a question, Steve? I think the latest I've read on this is that it's not useful for most. So it's the once compile flag essentially.
No, that's not true. It doesn't compile over and over again. It catches that optimization. You probably don't want to have a variable in the loop that changes, but you don't want the regex that interpolates that variable not to change.
If you generate regexes on the fly instead of closures, you don't necessarily want all
So this is further discussion afterward, but in general, don't use O. So, and also don't fall into the trap of using SMX. There was a certain individual that proposed that with the Perl Best Practices book, and I started running into code that has SMX randomly thrown in. That it made it harder to read because you go, why is this S here? Why is this M here? It's not doing anything, and it actually can break old code if you throw it in. Don't use them unless you actually need them. Yes, question.
What about the editing option?
Uh-huh.
Does that mean you turn off back references? So /1 would be nothing at that point, or /1 still work if you didn't have regex?
I haven't tested that. I think that I thought I read something that says that it actually works, but it doesn't populate $1, but I'm not sure about that. I know that it doesn't populate $1. That's something I'd have to try. Good question, though. So it's important that we understand how regular expressions work, that we don't end up being cargo cult programmers. And in general, modifiers can be placed in any order. It doesn't matter how you stack them on. Some examples here. The second item here is showing how to take a file in a single string and extract the second field out and put it into a list or an array. You have to use both the G and the M. That's been terribly useful. Yes?
What did you need a question mark here on that first field? What would that become the last field?
It depends on your data. If you can trust your data to not have errant colons in there, then you're okay. This is actually, we'll get into this a little bit later, but you're right. I could put a question mark there and I'd be sure it'd be the second field. Yeah, good point. And then the last one there showing us how we use the E so we can evaluate an expression. So in this case here, we're capitalizing a value. The next main operator that uses regular expressions is split. Split is usually more concise and efficient than using a regular general purpose regular expression engine. And normally the delimiter, when it matches, is thrown away. So some examples here, we're splitting a line based on a colon. We're splitting a line into two pieces where the first piece was before the comma, and everything else, no matter how many commas is in it, is in the second piece. The rest. The -1 is the limit. So the numeric argument is the number of pieces to break it into. The -1 means even if there are empty fields that are split, return them as empty strings. Whereas the normal behavior is if it runs into empty fields at the end, it throws them away. If they're before the end, there's values before the end, it'll keep all the ones up to that point. Actually ran into this lately. We had a config file format that was being read improperly. We decided, we need to use -1 on that. If you tag or parenthesize, capture that delimiter, it will throw it in the list that's returned. So you'll end up with all those, and maybe more than you want. Most of the time you're not interested in delimiter, but sometimes you are. So be aware that you can get that. So
Sorry, where are they returned? Are they returned
they're returned in the list. So in $ or in at all, every other element is going to be that delimiter.
Okay.
Oh, so go ahead.
Slide before that. You have delimiter in single quotes.
Yes. Performance-wise, I haven't noticed a difference. I actually haven't tested that performance-wise. I put it up there because I wanted to show that you don't have to have the 2 forward slashes. Split recognizes that next thing as a regular expression, no matter what kind of string you put it in. Now, some bad things to do. You shouldn't be putting a regular expression when really what you need is a string equality. If you're using a version of Perl that's before 5.20, you need to avoid certain internal variables that are heavily involved with the regular expression engine. This is not a problem anymore. So you don't have to worry about this if you're doing anything past 5.20. You might be able to play with those variables. It might help you with some debugging. You're supposed to be able to turn those variables off and the performance issues in the older versions by using English no-match variables. By the way, the translate operator uses the binding operator, and it looks a lot like substitute because it's got those 3 forward slashes, but its arguments are not regular expressions. So beware, there's a difference there. We'll talk a little bit more about that later. Also, do not use regular expressions for functions that already exist. Things like UC, UC first, and LC. Some of the common mistakes is using a dot star without a question mark. You're defaulting to greedy. Putting an or at the beginning, which means it'll always match because it can always say the left side matched because there's nothing there. So you have to be aware of that. And also the order, if you have pluralized things like egg and eggs, it'll always match the first one. We talked a little bit about this before. A better way is to probably just say eggs and put a question mark after the S so that the S becomes optional. We have to watch out that we're not greedy when we're supposed to be lazy. Creating an inclusive class rather than an exclusive class. An inclusive class is one where you actually list specifically the characters you're looking for. An exclusive class is where you're saying, these are the characters I don't want. Sometimes the one is significantly larger than the other, and it's harder to get it right when you're dealing with a large class, like all the punctuation characters. And I'll show you a way to deal with that as well. You need to know your data. Can you trust it? Can you cheat a little bit and be a little bit sloppy with your regular or general with your regular expression that you don't have to be as precise? That can have some big performance gains for you. And if you're not testing, you can get into trouble because all of a sudden something doesn't work. Unicode doesn't always work. And there's some reasons for that we can't get into here. Just be aware that you're going to have to dig if you have to deal with Unicode. Do not use the alternation vertical bar if you really are looking for a single character. Use the character class. So in writing regular expressions, focus on what is unique about the data, the pattern of the data. Know your data. Don't make your regular expressions overly complex and thus too fragile. This is a mistake I think a lot of us run into is we make fragile regular expressions and wonder why they stop working. Keep them as simple as possible. And you can use some pre-existing regular expressions that are out there in some modules like regexp common. And it also might be better to, instead of making one big regular expression that's very complicated, use various stages to do multiple regular expressions to check various parts of it. For debugging regular expressions, there is no perfect debugger, but there's some that are close. So let me show you a few things. You can do small parts checks in the Perl debugger, and I'll demo that in just a minute. You can also turn on RE debug. Now, this is not entirely helpful, but it can be because it'll show you what is the regular expression engine is seeing. There's some online regular expression testers. You can just Google for them. Most of them are set up for non-Perl things, so you have to be careful. Some of the syntax might not be exactly right. If it says PCRE, Perl compatible regular expressions, that means it should be standard. Regex 101 might be a good one there. There's another one on GitHub, grex-js, that can help you create them. It's not really a debugger. So I want to demo this here. We have regex debugger. This is written by Damien Conway. You have to install it to use it. And you run it by typing rxrx. So if I type rxrx, it starts it up, and it wants a regular expression and a string. So let's just do something really simple. So we'll say /abc. That becomes our regular expression, and then the string is, we have to quote, so we say 1, 2, 3, ABC, 1, 2, 3. So then now it's set up and ready to go and test. We tell it M for match, and then we just hit enter, and it just kind of steps through and tells you each step as it's going through, trying to match. You can just tell it to continue, and it'll just go and run through as quickly as possible, and you won't be able to keep up with it. But here I'm just stepping through, so you can kind of see how it does it. I've had some times where my regular expressions have failed, and I've had to step through it using this to figure out, oh, I forgot about that, you know. So that's how it does it. It actually does captures. It starts falling apart when it gets into some complex regular expressions, but it's very helpful. You can also have an interface with it where you run it with your Perl debugger. So you can say Perl -m regex xp debugger with your script, and it'll actually give you some help inside your script. Some of the predefined modules that are out there. There's a lot of them are stuff that you would probably be writing your own regular expressions for anyway, so you may not have any interest in some of these. Recognize floating point numbers. There's actually an interesting one. There's one about profanity, matching profanity, so you can find and this is actually useful. I worked for a company that did automatically generated usernames based on something that the user provided, and you can end up with goofy things because again, this guy's his account, he wanted to be named "The pen is mightier than the sword," and we truncated it 8 characters. And he was upset that his username was not what he wanted. Yeah. So some of the advanced stuff here, if you've seen sometimes these square brackets with the colons. These are the POSIX predefined character classes. A lot of them are stuff that you would do anyway. And you can also use the P notation for those as well. And there's a whole bunch of them out there. And these can be terribly useful. Let me go back here, because you can see that punctuation, you can also say not punctuation, so it'll get every character that is not punctuation. So that actually be very useful. And these change based on your locale. So that can be very cool.
Only that's not true necessarily. That is true only within the scope of the use locale.
Yeah, good point. Let's talk a little bit about named captures. You can name a capture. You use a left paren question mark, and then you in either quotes. I'm just showing here in the angle brackets. You put the name, and then you can reference that as $+ and then the hash, the name there in curly braces, or you can use as a back reference with /G with the name. So the example at the bottom is we're getting the month, day, year, and printing it out as year, month, day. Named captures are kind of ugly. They're kind of cool, but they're kind of ugly. So a lot of people don't like them. And I worked a place, the one guy started using them and they chased him out, basically. Stop doing that. You can turn off captures with the modifier N, or by putting a question mark colon is the first two characters in the group. The \n will, or the /n will actually turn off for the entire regular expression, whereas the question mark colon will turn it off just for that group. There's other things that have the parentheses with the question mark as the first character. There's things that you can have specific modifiers for just a group. You can add code that executes as part of the regular expression. I mean, it starts getting really off-the-wall stuff. Let's talk a little bit about anchors. We've seen these anchors so far, the caret and the $sign and so on. \b is a word boundary, meaning where we have a transition between a /lowercase w and a /uppercase w. So that's a positional regular expression. We also have as anchors what we call look-around assertions, where we have a zero width, meaning it's a position, not an actual bunch of characters. And we have a positive look ahead, and we have a positive look behind, so things that are in front of it or things that are behind it. They start getting quite complicated. I've got an example here. And it's typically where you're saying, I want this as long as it's not followed by this other thing. That's the kind of thing that you're looking for with these look around. And there's the negative ones. They're not as interesting. What's interesting about these is you can have these assertions next to each other in a regular expression, meaning they both are saying the same position has to have these two qualities, or so it has to not only have not this other thing, but it needs to have this other thing. But you don't want that as part of the match. You want that part only as the assertion. And having used Perl since 1994, I have never run into anyone using the look-around operators in production code. I'm sure somebody has, but no, I've not seen anybody use it. So you probably don't need to worry about them. We're running out of time, so we optimize regular expressions. We can do this by getting rid of some of the things that are causing looping within the regular expressions. Things like backtracking, nesting. Watch out for groups and back references. Those can cause you problems. If you're optimizing, use split if you can, or a string equality or string not equal. Break up your regular expressions into smaller pieces. That may help with maintenance as well. And one of the interesting things I ran into is TR, the translate operator, can tell you whether a variable whether a character exists in a string. And so what's helpful there is if you're really doing a match, looking to see if this a particular character is in a string, TR can do it for you, and it'll do it a lot faster.
Index is similar.
Yep, index can do that too. Now, outside of Perl, there's a few little traps because some of the syntax will change. And things we need to watch out for is that if you're using the shell, like for sed or grep, the shell is going to steal some of the characters and modify them. So you have to quote them or escape them, and sometimes both. And you probably can't use the shorthand forms like \d. Question back here. Oh, okay. Okay. Then let me jump to the end. Here's some examples of regular expressions in other languages. Here's some resources. Mastering Regular Expressions by Jeffrey Friedel is an excellent book, but the best stuff you're going to have is going to be online because it's going to be up to date. And no questions, answers. And then tomorrow I'm giving it the Perl Quiz 5 with prizes. So thank you very much.